So this is all about do-it-yourself action figures. This is a project that I did this summer to see if it was even possible to do. And what I'm going to do is walk you through a little bit of my background with this, and then all you need to know to get up and running, so that if you have an idea for an action figure, or actually anything that's mechanical and organic, it could be something else entirely, then hopefully by the end of this talk you'll have the confidence and the idea of just how you can go ahead and make it on your own. So I'm going to start with a bit of my history. Oh, wait, I'm looking over there. In 2005 was when I was first introduced to any kind of 3D modeling and printing. This was at school. It was really great to use. And that was the good news, just knowing it was possible. And that was great until you're out of school. If you don't work in an engineering studio that had that kind of equipment at the time, then you had a bit of a problem. So that's the second part, which has to do with the bad news. And then the last part will just be about how to build something on your own today. So here's a really old photo of something I did in 2005. These are actually 3D printouts, and unfortunately I don't have a photo of just the straight printout. This is one. These are example of doll heads that have been finished, surface finished. A bit are in the process of being dremeled out. And that's because as of 2005, 2007 or so, if you modeled something and printed it out, at least on the equipment I had access to, the print resolution was so poor that you really had to do a lot of finishing work to get anything approaching the smoothest that, well, at least I know I was looking for. And if you were doing a doll, it was better to actually do a lot of finishing before it was ready for anything. So here's the back of it. I had to do a lot of finishing work on a 3D printout. And that was the end of the project. I ended up doing a project in 2008. I had been introduced to all of this 3D modeling and printing in around 2005 to 2007. And then I realized if it's not at a school, if you don't have access to these things, then either you don't do the project or you do it the old-fashioned way. So I actually sculpted the entire doll by hand. That meant doing the right side, the left side, trying to make them symmetrical. When it came to parts fit, the whole thing was a ball-jointed doll. So I would get wooden balls and actually fit them together to actually get the joints to work. And you'd all do that by hand. If you mess something up in terms of scale or fit, or broke something, then, well, congratulations, you have to go and sculpt the entire thing all over again, because if that's your master sculpt, that is your master sculpt, and there's no backup to the master sculpt unless you made one, like a physical representation of it. So this was on display during Fashion Week in 2009, and for the purpose of the experiment, yeah, the dolls worked, but say that you're living in 1600 and you decide you're going to make a doll. Then you'll go make a doll and you'll do it by hand and you'll be at peace with yourself because that's the only way to make a doll. But if you're living today and you're working on these things by hand, unless you have some angle to it that you're doing specially where you like your fingerprints on it, or you want it to be asymmetrical on purpose, or it's got some kind of really unique handcrafted thing that really needs to be done by hand. Otherwise, if you know about this technology, at least my experience was, working on it and knowing there's a better way out there really bothered me a lot. So this was 2009 again, and after I finished this project, I did a little other one in 2010, but that was it. I basically told myself I am not going to do another doll or figure project unless I have access to the digital tools I need to do a better job of sculpting it and realizing it that in a way that matches my imagination and isn't so painful to do it as it was by hand. So that was then, and well, a lot has changed today. So that's the really good news. And what I did this summer was to go, okay, what year are we now? 2013, 2013, whatever you want to call it. When it comes to all of these CAD and modeling problems, either you can suck it up and shell out a lot of money to pay for the more expensive options, or you can suck it up and do it the old-fashioned way, which is what I did. Or I suppose the third option is to go build your own software, which I did not do. But it turns out today that if you don't have the budget, you're new to these things, there are tools you can use that are completely free and are on your laptop, so you don't need any specialized hardware, where you can completely do a figure from scratch. So this is the project I did this summer, and it started as a regular drawing, pencil on paper, and this was about 5.5 inches tall. Actually, I can kind of show you what it turned out as. This is the actual figure I finished with, but it started as a drawing that is 5.5 inches tall, very, very small, very, very detailed in terms of this is what I knew I wanted to do. And so if you see all the circles, and if you can see all of those numbers there, that was me mapping out all the dimensions of this is the figure, these are the sizes of the joints, this is exactly what I want it to look like. But it's in 2D, so I mean, if you like paper cutouts, you're set. But that wasn't it, that's not good enough. So I moved on to seeing what kinds of free software is there for me to try out on a project I don't even know if it's gonna work yet. I happen to start with a 3D CAD program. I work on a Mac. There are several options. I did the entire project on a Mac. It will work for you if you are on a Mac. In my research, I have found that if you use a PC, you actually have more options than I did. I ran into several software packages that looked wonderful and then I couldn't use, well, because I was sticking to the Mac platform at the time. But this is Autodesk Inventor Fusion. It's available from the App Store. It's not a free trial, it's free. I don't know why they're doing this, but I am not complaining. And I went ahead, and if you go back here and you see all those numbers, that was me measuring every single major point along the figure. So you see those little X's around the side of the figure and up and down? Any nods? You got it? When you see those X's, you'll see those little dots along the 3D CAD model. And that's how I measured it out. That's how I got from the drawing on paper to a kind of boxy version of the same figure on the computer. So this is a 3D thing that is in your computer. And if you can imagine, say this is a 3D thing on your screen, and you're using a regular mouse or touchpad. So you go like this, it turns. 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 That is how you use a 2D interface to manipulate a 3D object. Now in 2005, 2007, the only means I saw was where you had a pressure-sensitive stylus. You don't need that anymore. The software does that for you. So that's the good news. So I had, these are a couple examples of the body and the arm, but it looks really boxy and I wanted something curvier. So I imported that into another program. This is Sculptress by ZBrush. Again, it's completely free to use, free indefinitely. And I use that to make the boxy looking statue thing look a little bit more like something that's organic and looks more like a person. So you can see the face looks more like a face than a block. And the hand, which you can see over there in the bottom right-hand corner, instead of that boxy slice that I tried to slice down, you have something that's curvier and has fingers, and you could add fingernails if you wanted to, details like that. So once I was done with that, I basically had a little statue. So if you want a cake topper, or you want to do an Oscar, or well, some kind of award for something that doesn't move, hey, you're done. You can stop right there. But I wanted an action figure. So I added joints. And if you have any feedback for me on this, please let me know. When I started in CAD and then improved the model in Sculptress to make it organic, I found I could not re-import back into the CAD program. So who here is familiar with STLs for 3D printing? Yeah, okay. So from Inventor Fusion, you can export to STL, and you can take that file and then convert it into a format that Sculptress can use. So from A to B works just fine. But if you want to bring that organic model, the statue, back into A, this is Inventor Fusion, to add the joints inside it, it wouldn't let me. So that was unfortunate. So I could have stopped there and cried and went home. But I used NetFab, which is not meant for any kind of CAD, but you can rotate stuff and slice it, rotate stuff and slice it, rotate stuff and slice it. So in this program, I would have been able to stick a cylinder through and run it right through, and it would have taken 30 seconds. Since that didn't work, I rotated it and sliced it, and it took longer, but it worked. And I got a bunch of different joints in the knees, in the elbows, in the arms, in the neck, everything. and basically pull it off using, again, completely free software on a regular laptop. And when I was done, I would just print them out. And this is the very first figure I did. You'll notice that there's one left arm and there's one right leg. So another beauty of working on the computer is I just needed to sculpt one hand and one arm and one leg. And if those worked, then I could just mirror them over and print them out again. When I did the project by hand, I had to sculpt every single part by hand, kind of eyeball measure them, hope they matched up, kind of knew they didn't, but went with it anyway. Whereas here, there are some things that the computer can do better than you, period. Symmetry is one of them. So if you are not going for something on purpose that is asymmetrical, hey, do your one leg, do your one arm, do your one hand, do your one foot, and flip it, print it, be happy. So that's where that was. I just tried one arm and one leg. When those looked fine, I printed the other ones. And then I printed more figures. I started with the most basic figure you could imagine. If you can think of a statue where you just slice across here, 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 the waist, and so on, then you just have a figure that moves like at the waist, here, like that. Very, very basic. And then I held it together. Can you see my cursor? Does it move? Oh, great. Okay, so you see that kind of greenish blue dot? That is a regular sewing pin, and I just fed it right through the torso with both arms, and then it's a happy little figure that can move its arms that way. You can't really see here, but there's a pin that goes that way, and there was a pin that went right through the head and kept the head attached to the torso. And you know what? It worked. It was very basic, but it worked. But then, you know, that might be good enough for you, or you could get more ambitious. And I got a little more ambitious and did a second figure over here. And you might see that there's a knee joint. So if you can imagine a leg, and then if you sliced it just across the knee, then the bottom part of the leg would kind of twist, and that's not how a knee works. So I had to rotate it around, put a joint through the middle of the knee, and then actually, see that cylinder that goes through the knee on the right-hand side? I would cut around it so it actually could bend instead of something like this. So if this is like a foot, this is a knee, and this is a thigh, and this is a whole leg, then slicing it just across would lead to this. But if you have a round joint in the middle, then you can actually bend it. And depending on how much you take away at the back, you can bend it more or less. And with the combination of a circle, which is how it bends, and then the organic sculpt you have, because nobody has a knee that looks like a perfect circle from the side, you kind of can strike a balance between a figure that looks human and some joints that kind of move naturally. So that was the figure over here. And the figure over here was where I got even more ambitious, changing the style of the hip joint, changing the style of the arm joints. I am going to be very optimistic and hope you can see a little bit of this. So this is the tiny, tiny, tiny figure at its actual scale. All of the figures I printed, or that I designed, can do this. So they can all do that. That's not much. That's pinned through the shoulder. But only this one can do that. And the way it does it is there is a tiny, so I'm gonna mimic the figure because I figure I'm bigger. So it can do this, and it can also do that. And that's by adding a tiny slice that goes through the shoulder. And there's a disc. This is actually a picture of it before it went in. There's a disc that it rotates around this way, and then it goes into the middle of the torso, so in here, and there's a knob that's at the other end. So that knob keeps it from falling out. Because the knob is round, it means it can rotate around it. Because there's a disc over here, it means it can rotate this way. And to keep it together, I started with sewing pins, and I ended with, those are toothpicks. And the toothpicks keep it together and have enough surface friction on them so that if I do a little pose like that, well, okay, that one's getting loose, but in general, there's a bit more tension to keep it in a pose that you set it so you can, have fun with that if you want. So that was the experiment I did this summer. I would say it took me a couple of weekends, Whereas the previous doll project, I know I was working on it for months. I started in the fall of '08 and I finished in the spring of '09. And granted, I worked on it on and off, but it was months and months and months. That was my winter. Whereas this one, it took a few weekends. And you can get the same level of detail. All of that grunt work that the computer can do for you saves you a lot of time and gets you there a lot faster. So there's a picture of the finished figure that I've got up here. Later on, if you'd like to see it in person, you're welcome to come up and try it out. I set up a website just if you'd like to sign up. There's a tutorial I'm putting together that just documents every single step I took in creating the figure. When I started, I didn't know if it was going to work out, but I thought I would take photos just in case it did. So if you like how that turned out, if you go to DIYactionfigures.com, all it is an email sign up. And then hopefully on Monday or shortly after Maker Faire, I can just get that uploaded, write it out for you, and then send you an email link to that so you can read about it, know how I did it, know what the internal mechanism looked like before I closed up the torso, and know what kind of software to use in case, there's a lot going on at Maker Faire. The last thing you probably need to remember is the names of specific types of software, but I can get that in your inbox. And otherwise, if you have any questions for me and want to email them, that's my email address. And that's it. That's my talk. But please, if you've got questions, I'd be happy to answer any that you have. So, thank you. Any questions? Oh, yes, it is. So the original figure that you saw in the hand over there, you see this kind of sanding sponge here? That's what it looked like before it had paint. And it's just regular paint, regular spray paint, and it seems to be holding up so far. So if you don't like the color of whatever filament you have, that's okay. Also, something I should mention, if you don't have a 3D printer, get as far as getting the model done, and then you can send it to somebody else to print. You don't have to have a printer for this to work. There are lots of facilities available. I'm sure a lot of them are here, actually. So there are options, and you can come up with something completely new. It doesn't even have to be an action figure. It could be a bike, it could be a shoe, it could be like something mechanical, organic, a combination of both. So don't feel limited by this. Just, it's completely free. It works on Mac and PC. I think Inventor Fusion may be for Mac only, but Autodesk does have other software, and there are other software packages out there. Again, I found there were more options for a PC. So all you need to do is sit down, get to know the software. I found it was fairly easy to use. Once you find your way around and you try things, then it makes more sense. When you print something out or do one thing, you get more confident to keep going and going. And then, who knows what you'll come up with. So yes, it's spray painted. You got options. You could print it in glow in the dark if you wanted to. There's lots you could do. Any other questions? I think you had in the corner. Right. The file type, like what program I printed it from? Well, I used a Solidoodle 3. So this is an ABS extruding type printer. If you've heard of MakerBot, it's a similar type of technology where it's printing in the same kind of plastic that Legos are made of. There are other options. I have not verified this personally, but some visitors to my table have said that, wait, you could have taken this file and used a CNC machine. So there are other, you could use just about any kind of printer, I think. By the end of this, every file I had was in an STL format, and so I think that's compatible to many, many printers, CNC machines, and other things. So, does that answer your question? Yeah, I printed them out in parts. I have been asked, like you may have seen some 3D printer demo type things where we have, I don't know if it's called it's like a series of nested spheres that move around within each other. And the theory goes that this could not exist if it weren't 3D printed because they're nested within each other. Do you know what I'm talking about? It's kind of a squarish squarish sphere that moves around. So I guess that is an example where there is some kind of support material that is either taken away or washed away or somehow removed and the rest remains. This may be possible to do that way. Am I out?
There's a nylon printed material that you can use as a secondary, and it's actually dissolved using citrus acid from like orange juice.
Okay, so I've just heard there's a nylon material that can be the support material, basically.
You just print it inside, and it becomes a support material. You put it in like lemon juice or orange
lemon juice,
overnight,
yeah, okay.
Overnight, and it's gone.
Did you hear all that? So lemon juice, orange juice. Wow, okay, I didn't know that. But okay, apparently there are melt-away options. So that's something I have not tried. I'm not sure if I have a printer or access to one, but I'm definitely open to it, because then you could just theoretically print the whole thing and then wash away the inside so the joints work with themselves. I have not tried that, but I'm very intrigued. So, yeah, another thing to try. Any other questions? All right, well, thank you very much for coming by. I hope you're inspired to try stuff out. If you'd like to talk to me, I'll probably be over that way. So thanks again.